PYE Black Box Transistor amp. Someone's had a go at previously to try and fix. Got wires taken off here, off the capacitor, off the fuse. Looking on the other side, can't see anything there, so they've mainly been fiddling with this side. So it's just a matter of checking this rectifier, checking these transistors are the main things that go out. Also, I see a couple of capacitors have been changed by someone. This one and this one have been changed. Not normally necessary to change them. And looks like there's one change down the bottom as well. So, and there. I'll have a look. Be easy to test these, and this with the just an analog meter like this. All you need to do is connect it to one side of the rectifier, and then just check. For instance, on here, if it's not short circuit, is the most likely. It's not. It's reading the resistance, which is quite high on these old rectifiers. This one not blown. So transistors, check. You can check the collector through base and emitter. Just put a clip on there and check on this side. It's reading all right. Check the other connection down there. It's reading. Now on this transistor on diode, we'll do these two connectors here. That one is showing a reading. Now on there, there's a short circuit on this side between collector, and that's I'm not sure if that's the base or the emitter. So we've got a short circuit on this transistor. That's probably why it's not working, unless there's a short further down in the circuit. Lots of germanium transistors, which can go down. Generally they're okay. Also the switches tend to break on these things, but this one is clicking, so it's worth checking. Capacitor, I can check that with a meter. So first of all, let's have a go at this old germanium transistor. I'll get the circuit diagram out that I made earlier as well and check what it is. Right, first thing I find is that this transistor, which should be an NKT452, there's two of them on the circuit, one above the other. This one's been changed. Now they're on insulators, as you can see, including this, but whoever's put this in, this is short, so we've got a connection to this connection, and it's shorted to the back plate. So it's either not been put in properly, or it's got an insulation down there. So that's not. That's one reason why I think they've taken all these wires off of the transformer and everything. So they was looking for the short. But you can see this has been changed. It's physically bigger in size than the old NKT 452, which was a PNP germanium power transistor, 3 amps. I can see the number on that one just about. They've put in an AD149, so I'm just going to take it off and see whether it's just the installation that shorted it out. Taking the power transistor off to find that there's no insulator being put on. Whoever put it back, there should be a very thin a mica insulator between this and the heatsink. There's one on here. You can just see the edge and you can feel it with the end of a pencil. Whoever put this on forgot to put it back on, which is very strange. So I'm going to check this out, make sure that's working okay. I've got an insulator I can put back on, and I'm going to screw it back on, and then I'll continue checking out the rest of the circuit, and then reconnect these wires, and hopefully we can power it up and check all the voltages, see if it's working. This is the silicon mica insulator that should be on it, just a very thin piece, just slips over the emitter and base, and you can put some heatsink compound on it if you want to improve thermal transfer. Also, I've got this little analyzer which can test the HFE. Now, according to this chart which you can download, there's the NKT452 original with the basic specifications, and the HFE minimum 30 to 90, which we want to check. The 8149, it says 20 to 85. So the better the HFE, the better. Otherwise, all the other figures are better on the 8149. So you just take something like this meter, connect it up, analyze, and HFE 72. So that's good. So I can also I can check the other one and compare, make sure that one's working okay as well. Taking the wires off the other transistor so I can check it, collector and the other two. Unfortunately, it's not looking good. It's saying it's common cathode diode network, which it's not. So it looks like that transistor is blown. There's the old NKT 452 new market. See the construction they used to use. They had a center part with the germanium part in it, and then they stuck on a heatsink on the outside. The modern construction is different. Its heatsink is all one piece. So I've just got to fix them back in there, obviously with the mica insulators. There's one still on there, and put one there. And test some of these capacitors, make sure that they're not leaking. And the fuse is broken. It had like a rivet, and the fuse has fallen off, being old. But I can that'll probably just stay in place anyway once it's got a bit of wire on it. This is the smoothing capacitor for the power supply. It's only quite a low voltage, only 25 volts after the full wave rectifier, which is that. We can test it on here and just see if the capacitance, it's 0.24 ohm, capacitance 994, so it hasn't dried out or changed. The capacitance would change a lot if it dried out, so that's probably still okay. So I'm going to put it back in, and we'll listen to the hum later. This fuse in here is a 10 amp, it should only be a 1 amp, so that's much too large. This capacitor here I'm just going to test is the capacitor that feeds the speaker. So it's important that one's good, because you want a decent low resistance and good bass response through there. So I'm just going to check that one as well. Just put the clips on it. Sometimes you have to take it out of circuit to get a proper reading, but let's see what we get. So it says it's 1000 microfarad. I think it's only 12 volt rating. Anyway, let's see what it comes up with. 0.44. It's gone quite high. It might be worth changing that to a decent capacitor, as it's the one that the audio signal is going through, and it does quite a lot of work at high power. So I'll see if I've got something I can fit in there. All the other capacitors, as I said, some of them have been changed already by somebody. So someone's been through the circuit already. I've checked this. It's testing okay. I'm going to reconnect some of these wires, and after changing that capacitor, reconnect all the wires. and might power it up. I can clean these pots, they're not broken, thank goodness. Right, this capacitor here, which feeds the audio to the speaker, 1012 volts. I found this modern one, 4725 volts, which is going to fit in there nicely. I'm going to give an extended bass as well. 0.13 ESR and 4600. Right, ready to go with the DC tests on here. I'm going to ramp up the mains voltage in slowly on a variac just to make sure that nothing is going to blow. I've got a couple of voltage monitors. One here is in the center point of the output. Now this is supposed to be half the supply voltage here, so that when it's got a signal can go up and down like this. So we've got to monitor that point, and that is adjustable eventually by this potentiometer here, which is this big black one here. So you can set that output voltage. And secondly, monitor the supply voltage here to make sure that nothing is going to be too high or current too high, and the voltage is going to be all strange. So we've got one just on that point there, voltmeter here. So what we do is we set the voltage mains input to 0, and then as you turn it up, make sure that the current doesn't leap. It's got to remain low in this case, so you know there's a fault if you've got a lot of current coming out. And check the voltages here. This is the DC voltage, which should be minus 24 volts eventually when we get to full. This is the voltage at the center point, which should be half of the supply voltage. So we'll turn up the voltage slowly and watch and also listen and watch just in case an old capacitor blows or something's not right. We turn it up now. Okay, we're up to about input 200. Let's put it 220. Voltage is already at 23 volts at 220. So I'll just advance the voltage a bit to set it at 24 volts. That's 228 volts in. And the center point now, you can just see 8.95. We want that half of 24 is 12. So turning this potentiometer here while watching the display, we want 24. We want 12. So turn it one way or the other. It's down. So turn it near enough. 11. And 24. So with that set, next test is to feed in some audio. I noticed a bit of background noise, which was sort of noise you get from an old resistor, and I tracked it down to the front stage. This one here, this 330K, it was gone very high, nearly 500K, and when I changed that, the noise went away. It's just down at the front end, just down there. So that got rid of some background noise. One more fault to fix on this amp. Replace the output transistors with 149 germaniums. I've replaced this transistor here with a modern low noise silicon transistor, which you can use here. It doesn't have to be germanium. Replace the resistor here, which was making a hell of a noise. Remember, they're carbon composition, so they can be very noisy, especially on the input. And generally fix the wiring. But there's another problem now. You can see that running at about 24 volts on the supply rail here, and the split rail about half, which is here, which is fine. But as soon as you start applying a signal, I'll show you, in fact this transistor here, this AC127, breaks down. It's working at the moment, which is I'm going to turn up a 1 kilohertz tone, and I'm going to turn the volume up and watch the rail voltage here. I'm measuring the power output. As you can see, there's nothing at the moment. So starting to turn up the tone volume. We've got now monitoring the this is the signal on the speaker output, and this is the signal to this transistor here on the base. The supply voltage is falling a bit. It's about 3.5 watts RMS. And as that transistor heats up, it's going to fail any second. There you go, 0. The voltage is gone, and it's drawing a bit of current's gone up as it's drawing it through that output stage. So I can turn the signal back down, but it's just stuck now at 1.4 volts. At this point here, so that transistor, as it heated up, it suddenly failed. So let's turn this off. Now I can use some freezer spray on that transistor and cool it down again. It'll start working again. So it's very obvious it's that transistor. So I've got a modern, not modern one, a better transistor. Problem is it's an NPN, which is unusual for a germanium transistor. NPN AC127. You can't put a silicon one in there because the circuit balance will be wrong. You'll have to change everything else. So this is an NPN. It's a better spec. It's got a higher breakdown voltage, as the AC127 only had a 12 volts breakdown voltage. This has got about 25-30 volts. I've also tested it, and it's got a good HFE, and it's good because if you buy old transistors in new old stock, sometimes they can be no good, so you've got to test them. Make sure I know the connections. Also, it's got a heat sink on it, which means it's going to be better at not overheating and failing. So I'm going to put that one in and redo the test, and hopefully everything's going to be fine. So I put the replacement AC176 in. Temporarily I've tacked it on the back of the circuit board. You can just see it sticking up there. Voltage 24 rail, 12 volts split. I've got no signal yet, but I'm going to start turning the signal up. You can see it coming up. The output, which is the yellow one, is peaking out there. And it's 5.35 volts. It's about 4 watts across 8 ohms. Still stable. Rails dropped to 20 volts and 10 volts. We've got about 230 volts in. So it looks like I'll just put some music through it before I take this board out and put this in its correct place down there. Just checking it, just playing a track from the iPad. Got a speaker underneath the bench, so quality sounds pretty good to me. Just checking the sound, playing it through, it's not a hi-fi speaker, but it's a good speaker anyway. Julie London. Get me some money too. Goes pretty loud. Oh, do it. And the treble cut.
Kiss on the hand may be quite continental, but diamonds are a girl's best friend.
That'll have to do. At least it's working. It's about as good as I think it should be